Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2238, indicates an issue with the air-fuel ratio, AF sensor, specifically sensor 1, which experiences low voltage in the input circuit. This particular sensor is vital as it measures the air-fuel mixture coming into the engine, providing essential data to the engine control module, ECM, for proper fuel management. When the voltage signal is lower than expected, the engine may not perform optimally, leading to issues with fuel efficiency, emissions, and overall engine performance. This error typically occurs in vehicles within the Honda Civic line from 2016 to 2021, encompassing various configurations. Ensuring accurate diagnosis and repair is crucial to maintain the vehicle's performance and compliance with environmental standards. The AF sensor, sensor 1, is located in the exhaust system, strategically placed before the catalytic converter to measure the oxygen level in the exhaust gases. This sensor plays a crucial role in determining the air-fuel ratio, which is essential for optimal combustion. The engine control module, ECM, also known as the powertrain control module, PCM, processes data from the AF sensor to adjust fuel delivery accordingly. The input circuit, IP circuit, is the pathway that carries the voltage signal from the AF sensor to the ECM. Low voltage readings can impede the ECM's ability to regulate engine performance effectively, leading to potential drivability concerns. The affected components must be examined thoroughly to confirm the issue before proceeding with repairs. Several potential causes could lead to DTC P2238. A shorted wire in the input IP circuit can create a low voltage signal, affecting the performance of the AF sensor. This wiring is crucial as it serves as the communication line between sensor 1 and the ECM. A faulty AF sensor itself may provide inaccurate data due to internal breakdowns or damage. Lastly, a malfunctioning ECM can misinterpret signals from the AF sensor. Understanding these possibilities is vital for pinpointing the issue and ensuring an accurate and efficient repair process. It's also essential to review whether the vehicle has displayed any diagnostic snapshots or intermittent failures that might provide insight into specific causes. When DTC P2238 is present, several noticeable symptoms may arise. Drivers might experience poor fuel economy due to incorrect air-fuel mixture adjustments by the ECM, leading to excessive fuel consumption. A rough engine idle can also occur as the engine struggles to maintain proper operation with inaccurate data from the AF sensor. Additionally, you may observe increased emissions as the engine may fail to burn fuel efficiently, which can lead to failing an emissions test. Recognizing these symptoms promptly can help in diagnosing the underlying issues associated with this DTC, ensuring that the vehicle remains compliant with environmental regulations and performs optimally. The first step in troubleshooting DTC P2238 involves verifying the problem. Begin by turning the vehicle to the on mode, which powers the vehicle's electrical system without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs, resetting the system for new readings. After resetting, start the engine and hold the speed at 3,000 RPM without any load, ensuring that the vehicle's continuously variable transmission, CVT, is in the park or neutral position, or the manual transmission, MT, is in neutral. Continue this for a brief period until the radiator fan activates. Then let the engine return to idle. It's crucial to check for pending or confirm DTCs post-test to identify if P2238 persists, indicating a confirmed issue. If the DTC reappears, it signifies that a failure is consistently present, guiding you to proceed further into the troubleshooting process. In the second step of troubleshooting DTC P2238, begin by turning the vehicle to the off-lock mode to ensure safety while working on the electrical systems. Next, use the HDS to jump the SCS short circuit line, waiting for more than 1 minute for proper diagnostics. This process allows the system to prepare for electrical tests. After performing this jump, disconnect the connectors from the PCM and the AF sensor, sensor 1, to isolate them from the circuit. Then, check for continuity between two specified test points, PCM connector E, ADP, number 48, and body ground. This check verifies the integrity of the input IP wire. If continuity is present, there may be a short within the wire itself, indicating the need for repairs. If no continuity exists, it implies the IP wiring is intact, allowing you to move to the next step. The third step involves checking the A-FAT sensor, sensor 1, directly. Start by substituting the existing A-FAT sensor with a known good unit to rule out the possibility of the sensor itself being defective. After substitution, reconnect all previously disconnected connectors to ensure a proper electrical connection. Once everything is back in place, turn the vehicle to the on mode again. Following this, reset the PCM using the HDS to clear any stored DTCs and allow the system to recalibrate. After resetting the PCM, perform the idle learn procedure, which helps the engine manage settings properly for optimal performance. Subsequently, check for any pending or confirmed DTCs using the HDS. If P2238 is still indicated, it might point towards a problem within the ECM. Therefore, authorized service information regarding this DTC should be consulted or consider substituting with a known good ECM for further diagnosis. After completing the troubleshooting process and implementing repairs, the final verification step is crucial. Start by clearing the DTC using the HDS to ensure that previous fault codes are removed from the system. Subsequently, it is essential to take the vehicle for a test drive to observe the engine performance under typical driving conditions. This step will help verify whether any previously observable symptoms, such as rough idle or poor fuel economy, have been resolved. Lastly, after the test drive, recheck for recurring DTCs with the HDS to ensure that the repair was successful and that no new codes have emerged. This final check validates the effectiveness of the repair and ensures the proper functionality of the AF sensor and associated circuitry. To prevent future occurrences of DTC P2238, regular maintenance and inspections are essential. First, consistently check the wiring associated with the AF sensor and other engine sensors to identify any wear, fraying, or exposure that could lead to electrical issues. Secondly, ensure that all connections at the sensors and the PCM are clean, tight, and free from corrosion, as loose or oxidized connections can lead to intermittent failures and codes. Moreover, using quality replacement parts during any repairs is vital for sustaining the performance and longevity of the vehicle's emission system. These proactive measures not only help prevent future DTCs, but also enhance the overall reliability and efficiency of the vehicle, ensuring peace of mind for the owner. In summary, diagnosing and addressing DTC P2238 requires a thorough understanding of the role of the AF sensor and its connection to the engine control module. By carefully following the outlined diagnostic steps, technicians can effectively identify the root causes, whether it's wiring issues, an AF sensor malfunction, or ECM-related concerns. The troubleshooting process should be detailed and systematic, ensuring that all potential issues are examined before concluding repairs. Furthermore, implementing regular vehicle maintenance routines can significantly reduce the likelihood of encountering this DTC in the future. Staying informed and proactive not only ensures smooth vehicle operation, but also contributes to environmental compliance and optimal performance. Please like and subscribe to the channel. See you next time.